Hello, my name is Bob Frey. I'm the planning director for the Tampa-Hillsborough Expressway Authority. Thank you for coming here. Invited to come up and talk a little bit about our pilot and talk about where we are and give some lessons learned. First lesson learned that I guess I'd like to bring up is keeping control of your outreach and communications people, or you end up wearing shirts like this. I learned that lesson too late, and now I'm stuck. So that's an important one. Basically, CV pilots, as you know, in the previous presentation, we're talking about what we're looking for is from the Tampa-Hillsborough Expressway Authority. We're an independent toll authority. We receive no state or federal tax dollars to operate our road. We're 100% user fee driven. So for us, I get asked the question a lot, why would you get involved in this? Why would you spend the $100,000 that my board approved for a proposal? Really, we were a long shot to win. We were the smallest agency that actually applied of the 52 that did apply. Why would we do that? Well, as a small independent toll authority, we were the first in Florida to go all electronic tolling. We were the first in the world actually to build an elevated reversible toll lane that we operate. New technology is how we stay relevant. We need to provide a better ride for our customers than the competing roadways, or we don't exist. So I think that the toll authorities is a really good place to test this technology, because if it doesn't work and it doesn't perform, I guarantee you funding's already will not be there. I've actually been told that by my executive director, my chair, and others. So we reward what merits the expenditure. So that's what we're looking at right now, is safety and efficiency. How can we increase the throughput through new technologies and increase a safer ride? And the third thing that I was told to do was to shamelessly promote Tampa Bay whenever possible. So I've been doing that for the last 2 years. You've already seen this. As I mentioned, there were 3 phases. The first phase was a full 1 year of planning, ConOps, systems requirements. Went through that. The amount of deliverables that our friends at USDOT require is very significant. That was done with $2.4 million for us, contract, 100% federally funded, which we appreciate. Phase 2, we're in our design and deployment. We are now deploying right now. Our design is complete. We have our roadside units being deployed. We have onboard units being put in vehicles. As a DOT and a public agency, that's one thing. That's one pleasure you'll have to avoid. You'll avoid is retrofitting onboard units into the public's vehicles. Besides my other jobs, including we're building a $290 million bridge, and we have trails and all these other things we're building. I also run a car dealership now on the side. We have with HCC, Hillsborough Community College. We got together with their auto maintenance program. They supply most of the car dealerships with mechanics. So they're now installing the onboard units in the public volunteers cars, and they're getting a certificate in this, and they're pretty much the only ones in the country that have the experience putting connected technology in. So that's something we're doing. But it also comes with all the problems that you'll see with a normal car dealership. Appointments. They didn't put it where they said they were going to put it. The guy was rude to me. It's all the little things that you think about when you're running a gas station or something along those lines. That's interesting. Phase 2 is 20 months. That was done as a cooperative agreement. We, THEA, the Expressway Authority, we put up the total local match, which is going to turn out to be $3.8 million, and we're going to get $17 million from the feds on this project. April 30th, we go live. We're right now setting appointments. We're getting the onboard units put out into the vehicles. We will be live for 18 months and ending October 31st of 2019. I thought that was sort of interesting that Halloween was the end of our date. They're telling us something. Those who have not been to Tampa, Tampa in Central Florida, our pilot deployment area is in the Central Business District. The roadway along the top there comes right down into downtown, our reversible lane segment. It's funny because when you go to these meetings, ITS World Congress, IT annual meeting, connected vehicles, all the sites they show get together. You know, how many vehicles you got? It's like trying to see who has more vehicles. We have 1,600, which is not a lot. But one thing that we do have that the others don't is we're using our toll customers. So they're getting a 30% discount on their tolls to take part in this for those who use our reversible lanes. That means I get good frequency. I know how many vehicles I'm going to get Monday through Friday, in the AM and the PM. I'm going to get them there every time. So our frequency, our units may not be as big as some of the others, but our frequency is going to be very high. And so when people ask me, how did you get the public to take part? We bribe them. This is our deployment area. As you can tell, the different types of applications we're looking at. Meridian Avenue, the blue line right down the middle here. When you come off of our reversible lane, which right on the top of the purple that comes down is the end of our reversible. That is a reversible lane segment that we operate. Meridian Avenue at the bottom. Anyone who's been to Tampa, you make a right turn. Amalie Arena, 260 days a year they have events going on. 83 are Lightning games. And if you make a left, it's Port Tampa Bay, the cruise terminals. So we not only have a lot of activity in this corridor, a lot of events in this corridor, we have a lot of tourists in this corridor, so they never really learn the traffic patterns and how things work. We were putting a kiosk in the cruise terminals for the cell phone applications so that they could be on the grid. We're doing it in English, Spanish, and German. Apparently Tampa is a very big spot for the German cruise ships, which the things you get to learn when you work in this job, it's incredible. So this is what we're looking at. Participants, 1,600 public. As I've talked about, they will be receiving toll discounts. That's pretty much how we've got them to take part. 500 cell phone applications, only Androids. We learned that Apple does not play well with others, so we said they're not in it. We've got 10 transit buses, and finally 10 historic trolley cars. Historic is the operative word. What seemed like a great idea at 2 in the morning, about 2.5 years ago, has turned into sort of a problem. Number one, they're historic. You can't drill into them. You can't do anything because you can't change them. So they've got 1908 electrical systems. So trying to marry the new technology to the old electrical system. We're doing it, but it's going to probably cost as much to do those 10 trolley cars as it's going to cost to do probably about 700 of the other vehicles. It's just another lesson learned here. Fixed fee contracts, huge. Transfer the risk to the vendor and make sure they can do it because they're the ones who are eating that, not us. So it's funny, at World Congress they asked, how do you manage the vendors? How do you get everybody going in the same direction? And that was my answer, fixed fee contracts. And everyone laughed. And Kate Hartman from USDOT was the moderator going, no, he's serious. And I'm like, yes, it's the same as a design build. Transfer that risk as much as possible and have them deal with it, not you. So that's pretty much where our participants are. These are applications. We, as an operating road, what we did was H&TB is our GEC. We went out and did traffic engineering studies along the corridor. We did a safety audit, found out where our real problems were, and then we brought Siemens in, who's providing our roadside units, showed them the problems and asked them what they have to solve the problems. We didn't come in with a want list of this is what we want to do. We let the road dictate to us what needed to be done. And I think that went a long way in why we were successful in doing this, because these are problems that a lot of people, a lot of areas have. Morning backups, our reversible lane could go, we can have a backup up to 3/4 of a mile in the morning. That's a huge issue that we're trying to solve. On this, we're using forward collision warning, emergency electronic brake light, end of ramp deceleration. It was originally curb speed warning, but our friends from CAMP and the original equipment manufacturers got all upset because of vocabulary. So we ended up having to, because we really weren't a curve speed warning, we were an end of ramp. So that was like 8 months trying to find out what was bothering them and why they wouldn't approve it, until finally in the end we found out, you could call it Alice for all I care. Just let's keep the thing moving. But it's funny when you're dealing with the different industries on this. Telecommunications industries and the OEMs especially. They have different vocabulary, their standards and specs are different, their motivations are different from the road operator. And that was a huge obstacle to overcome until we started figuring out where they were operating from. And then the end of ramp deceleration I like a lot, because this one's sort of it's dynamic. As the queue changes, the distance that goes and the speed that we warn changes as well. So it's constantly changing based on the travel conditions. It's not a static application that you hit one point. Little things we didn't realize that, well, as we brought up, that the others didn't realize. MUTCD. When you're putting signs on your, into the vehicle, you need to be consistent with the rules of the road and where the signage, and try to stay as consistent as possible. We actually brought that up, trying to. The OEMs got mad at me for this comment, but you can't set these based on focus groups. This is what the public likes. There's certain engineering rules that we need to maintain and go and work with. So that's one of the things that we brought up. And then finally, this last one is called ISIG, which I find really interesting, because ISIG will basically manage the traffic signals along your corridor, looking for natural platoons within the green time. What we learned on this was that the saturation rates for ISIG have to be about 70% for you to start really getting any benefit from it. This required that we had to use traditional, basically we have to use traditional monitoring to do that. We're using video. We had FDOT stepped up with $500,000. We added $500,000 of video detection in downtown Tampa, because all the signals were pre-timed, so they didn't have the detection in place. So now we have video detection in there. That is providing us pretty much with about 80% of the data. But as we get more connected vehicles, we rely less on the detection. So from a perspective of a road operator right now, when you're going forward with your signal detection and intersection detection, this can be used in the future for the connected vehicles and help provide additional information. Wrong-way drivers, in Florida we have a huge problem with this. I don't know if those of you who have ever been down south in Naples, but the signs are as big as these walls, because we have a lot of elderly population as well. What we have is an application now that in the car will tell you that you're in the wrong lane, you're making the wrong turn, you've made the wrong turn, and then finally you're going the wrong way, and Florida Highway Patrol has been alerted. We actually have the last step we're looking at is how do we detect and tell people down the line. And there's some really interesting concepts with LED lights in the future, when you change over to LED lighting connected with that, where you can actually change the color of the light to let people know that in that corridor you have a wrong-way driver. This is one that we'll be demonstrating next week for elected officials and US DOT. And these are the different applications on there that we use. Pedestrian safety, as I mentioned, we're in a high active pedestrian corridor. Tampa's changing. What used to be industrial in the downtown now is becoming residential condos. They're taking away our travel lanes left and right. We've got bike lanes being put in all over the place for those lucky 44 people a week who use them. So we need to, we're using technology more to work with the pedestrians, because we're going to have more pedestrians in the corridor, less lanes, and 60% more vehicles. Something's got to give. So we basically have been working with the cell phones, and we use cell phone apps at certain locations where right now we're using LiDAR, which is expensive and we don't want to use, but there are technologies coming that can actually read the crosswalk. This is one of those by the courthouse where anybody steps in the road and everything has to stop randomly. You just don't know when it is. And we have a lot of near misses here, so we're trying to hope that helps helps out with the pedestrian. A lot of people are excited about the message you get on your phone, but I'm more excited about that your phone lets the 3,500-pound vehicle know where you are on the grid, because the way that it's read in the system is you're viewed as a vehicle, the same way as anything else, and it tells the driver and the connected vehicle that you're there. So that's a huge benefit from what we see. Transit signal priority. Once again, we're working transit into this. We're on a commuter route into Tampa with that, and we'll be working with the transit signal priority and then a pedestrian transit warning, as well as ISIG. And streetcar conflicts. Right turns in front of the streetcar is a huge issue. This is a real picture. It wasn't staged. We have that. And finally, traffic progression. We're trying to move things through more efficiently. As I said, less lanes, more vehicles, more conflicts. How do we move this through? We're hoping our next stage would be to actually use connected vehicle and RSUs on our roadway to help with mainline backups and to try to operate and coordinate the systems throughout where we can flush our exit ramps further into the city by coordinating. There's a question earlier where they asked who's going to maintain this. City of Tampa Traffic Management Center, maintains that. Another lesson learned here, and this is just general common sense for any programming, make it a line item. Connected vehicles is a line item in my budget now. We had to agree as part of the US DOT contract that we would maintain this in perpetuity. So we have that's in there, and we're going to use that to build on it. As I said, City of Tampa Traffic Management Center provides the information. The RSUs provide the information to the vehicles, and it comes back. And in the transit vehicles and the pedestrian and the trolleys, they're going to use tablets. This is what the RSUs look like. They're just like any other piece of ITS equipment. We did it a little differently because this was a different type of procurement. Siemens was on our team from the beginning. They helped come up with the ideas and helped us. So we basically were like a consultant team, putting together a consultant team and then sending it to US DOT. Once we were selected, they're on our team. So we're able to use them for various pieces of this very easily. We're using the rear view mirror in the car to get the message and get the information done. The logic there being everybody, including my 16-year-old son, knows how to use a rear view mirror, or should. A tablet would mean people are going to have to change their direction of their head, and we didn't want to add distractions. So we're basically replacing these mirrors, as I stated at Hillsborough Community College. Brand Motion, they're a Tier 1 auto supplier out of Detroit, is on our team that's supplying the mirrors. So the end product is the same as if you went into a Ford dealership and you replaced your mirror, you come out with the exact same product. We learned a huge lesson on the difference and the cost difference with automotive grade versus other grades of tablets. When you're talking to people, especially in the OBUs, that's a huge question, is what they're supplying to you automotive grade, because that's what it's going to have to be if it's going to operate in the car for any period of time. And the cost difference is very big. Why do we, as I stated earlier, why do we do this? For us, it's coming. This is, whether we like it or not, whether we agree with it or not, it is coming. I was skeptical at first. I thought it was a flash in the pan, but one of our projects, I was talking with my executive director, we were discussing this, and we were, our video told that we were changing the back office system, and we were using a company called Frey from Europe. And the engineer that was in the back of the room said, oh, I worked on the autonomous vehicles in my first job. And, we were looking at him, and he said, in 1974, his first job coming out of engineering school was to work with Mercedes-Benz on automated parallel parking. And his second job in 1978 was how to have the roadways talk to the car. So the automotive manufacturers have been thinking about this since the 1970s. And they've been putting resources towards this. Then you go out to Silicon Valley and look, we went to TRB, Autonomous Vehicle Summit that they had out there, and you see the money behind it and the companies that are putting on it. It's coming. Whether we like it or not, whether we as engineers or road operators think it's foolish, if it's foolish, we're going to have to deal with it. So we chose to be on the front end and at least have a seat at the table trying to make sure that little things like the MUTCD is still taken into consideration when they figure out when they're going to stop a vehicle for an automated vehicle, because it wasn't before, working with ASTRO and things along those lines. For us, we want safety as number one. Number two is operations of the road. We increase our throughput. Our director of operations and I, we sat down and did a little speed harmonization. You showed it as an eco. We showed it as, we have a piece of our roadway that is now becoming congested. And people won't pay tolls on a congested roadway if they can help it. So how much does it cost to add another lane in each direction for 16 miles? We're looking at about $200 million project. We have $75 million of bridge work has to be done no matter what. So we're down to about $125 million. We had our GEC and Siemens put together a speed harmonization project for us for that road to see what it would come up with. $50 million. So 75 and 125 million. We're saving 70, if we do this project, we could save 75 million. Is it going to prevent the road widening? No, but it could put it off for 10 years. It cost me 15 million to resurface. That's 4 resurfaces I can save on that project rather than doing that right now. So yeah, this technology is big safety and efficiency, but there's also some capacity savings that we could have in this. And if we can start saving money in those types of increments, where we're pushing off 125 million for 10 years, that makes a huge difference in our business model. So we think it's worth looking into. I put this in there because I'm not sure if systems engineering is big up here, but it's down there. Anytime I go to the ITS World Congress or something, I swear there's some guys that have this tattooed on their arm. We've already gone down the left side. Right now we are at systems validation, and we're moving to phase 3 in April. We're looking forward to seeing how this stuff, if it works and if it does it, what it's supposed to do. Please feel free to give me a call. Next week we're having the Florida Automated Vehicle Summit is in Tampa. We'll be putting it on as well. We're love to see if you're ever down in Tampa to come out. We'll show you what we got, and we'll answer any questions, or if we can't, to hook you up with the right people who can. Thank you.